Let's take a look at graphing rational functions. I have 4 examples in this video that all have a little something different about them. So for example 1, I just have 4x over x minus 2. There are no common factors that we can cancel out, so there will be no holes. The vertical asymptote is x equals 2, since that's where our denominator would equal 0. The horizontal asymptote would be y equals 4. That's because the degree in the numerator and denominator is the same. The x's have the same exponent. So we just take 4 over 1, and that's where we get 4. So I sketched the horizontal one in red and the vertical one in blue. And then after you sketch those lines nice and neat and make them dashed, you need to test some values on either side of the vertical asymptote to figure out where your branches go. So I tested 0 over here on the left and 3 on the right. So when I plugged in 0 just back into the original rational function, I got 0, 0. So that tells me my branch belongs in this area of my graph. And then I plugged in 3, so I got 3, 12. Now that is off of my graph, but it tells me enough that I can still put my branch right here. Then I can pick out domain and range. So domain is how far the x goes left to right without any limitation. So like x can go from negative infinity up to this blue dashed line, which was 2. And then after that, it can continue on, and there were no holes, so we didn't have to worry about that. So I wrote that here. Range is similar. We go from the bottom of our graph to the top of our graph and look at what y can't be anywhere in that space. So negative infinity is the lowest possible value, up to 4, and then it can't equal 4, so we put parentheses. But then it could be anything above 4, so we put 4 to infinity. Then some other stuff we've been talking about is the x-intercept, y-intercept, and symmetry. So I put those over here. The x-intercept you can always find by putting your numerator equal to 0 if you haven't already figured it out by graphing. So this one we can look at right there and see 0, 0, or we could set our numerator equal to 0 and solve. So I got that the x-intercept is at the origin, and the y-intercept was also at the origin because we had already plugged that in earlier. Then symmetry means to plug in negative x and see if all your signs change, which would make it odd, or if none of them change, which would make it even. So for this, I decided that it had no symmetry, because some signs changed, but not all of them. So you see the numerator changed, but then only the first term in the denominator changed, but that last negative 2 did not change, so it's not symmetrical. So that's it for example 1. The next 2 graphs are similar because they have 2 vertical asymptotes each, but I am going to cover up one of them because that's a lot to look at once anyway. So for the first function, we have 2 over x squared plus x minus 2. We need to factor out the denominator, and then we see that we still can't cancel any common factors, so there were no holes for this example either. Then our denominator would equal 0 at x equals negative 2 or at x equals 1. We have a horizontal asymptote at 0. That is because the degree in the denominator is larger than the numerator. So we just have that automatically at y equals 0. So I graphed those asymptotes. Make sure they're dashed. Then we have to plug in values in each region of the graph. So on the left, in the middle, and on the right. So I plugged in negative 3, 0, and 2. And you can see my work right there, and I plugged it into this original function. I got negative 3, 4, which told me my little branch belongs up here. I got 0, negative 1, so it just belongs down here at the bottom like a little parabola. And then 2 and 1/2 tells me my little branch belongs over here. So then the domain we can pick out. There are no holes, so we're just looking at asymptotes. The domain can go from negative infinity up to negative 2. It can go between negative 2 and 1, and then it can go from 1 to infinity. So notice we don't need any brackets. Those are all parentheses. Range can go from negative infinity to 0, and then from 0 to infinity. And again, there were no holes affecting either one of those, so we didn't have to worry about that. For x-intercepts, on this graph we have none because it will never touch the x-axis. The y-intercept we already found over here was 0, negative 1. And then for symmetry, I plugged in negative x, And this sign would stay the same, this one would change, and this one would stay the same. So it had to be no symmetry because some signs changed, but not all or none. So no symmetry. Now let's look at this third example, which had something different about it. So I'm going to cover up that one now. Alright, so example 3 was 2x over x squared minus 4. So we factor out the denominator. No factors cancel. So we still have no wholes. We still have 2 vertical asymptotes because there were 2 places the denominator would equal 0. -2 and +2. The horizontal asymptote would still be y equals 0 because the degree in the denominator was larger than the degree in the numerator. And then I meant to delete that one little spot right there, because that was just not quite right. Okay, so that's gone. But then I sketched my vertical asymptotes, sketched the horizontal asymptote. Then you have to check values. Whenever you have this middle area, like this other one did over here, you want to check for 0. And then if it touches at 0, which this one did, you'd want to check a few more values to figure out what the graph looks like in between there. Because there are some functions that pass through the origin. So I checked -3, and I got -3, -6/5. So I needed to put that point a little lower right there. And I graphed my branch down at the bottom. In the middle, like I was saying, it did touch at 0, 0. And then I had to check some more points to see how it curved. So I put those over here. I checked 1 and -1. So I got 1 and -2/3 and -1 and 2/3. And that showed me how it fit in the middle. And then I checked over here to the right. 3 gave me 6/5. So that told me my little branch was up at the top. Then domain and range are similar to what we've already been talking about. So domain goes from -infinity to -2, from -2 to 2, and then from 2 to infinity, and there were no holes. The range is from -infinity to 0, and 0 to infinity. And only in that one spot did it pass through 0, so we include that right here. We do have an x-intercept and a y-intercept at the origin. And when we checked for symmetry, we plugged in -x for both. So the top would change, but then only the first term and the bottom stayed the same, and then that one stayed the same. So change and stayed the same means that we would have no symmetry. All right, let's look at one more example. So this is example 4. We have x minus 2 over x squared minus 4. So I factor out the denominator, and then I have a factor that canceled. So x minus 2 cancels out, leaving me with 1 over x plus 2. So then I have a hole that would occur at x equals 2, because that's where each of those factors would have equaled 0. My vertical asymptote still comes from my denominator, but now it's the simplified form I'm looking at. So that is just x equals -2. The horizontal asymptote would still be 0 because my degree is still larger in the denominator. And you can check the original problem or the simplified form to pick that out. So then I graph my asymptotes, and I got to figure out where these branches go. So I checked -3, which is over to the left of the vertical asymptote. And I checked 0, which is on the right side of the vertical asymptote. So I got -3. And remember, you plug those in up here at the top, just in that original function. So -3 gave me -1, and then 0 gave me 1/2. So then that tells me where my branches go. So after we put our branches in place, we put the hole at x equals 2. And then you want to go ahead and figure out, like, what would the y value be if your hole is at x equals 2. So you just plug 2 into your simplified form, and you get 1/4. That'll help us when we write the domain and the range, because your hole affects both of those. So for domain, you go from -infinity to -2, -2 to 2, where the hole is, and then 2 to infinity. For range, you go from -infinity to 0, because that's where our horizontal asymptote was, from 0 to 1/4, because that's where the hole is located, and then from 1/4 to infinity. We would have no x-intercepts for this graph because it had a horizontal asymptote at 0. Then our y-intercept, we had already figured out over here, is 0, 1/2. And symmetry, if we plug in -x into the original function, I just use the original one. We figure out that this first sign changed, but then this bottom one would stay the same, and then this one would stay the same. So since only some signs are changing here, we have no symmetry.